All right, so here's an example of factoring and solving, then doing a sketch. And it's not going to be that difficult because it's a square problem or quadratic. So we know what quadratics look like, but using the same mentality here, this one's actually going to be really interesting. Okay? All right, so let's take a look at this. Let's do x factoring because that's the method you want to go with first because it's the easiest and most common and it works in many situations. Except in the ones that it doesn't, obviously. All right, so to get the number on top, we do 1 times 4, which is 4. The number on bottom is b, so that's -4. So two numbers that multiply to give me 4, but add to give me -4. Well, isn't -2 times -2 equal +4? But -2 plus -2 gives me -4. And because a is 1, I can take the shortcut here, and my factors are going to be x minus 2, x minus 2. Great, I set each one equal to 0, so x minus 2 equals 0, and x minus 2 equals 0. But now I finally recognize, well, wait, they're the same exact factor. So even if I solve them, won't both of them be x equals 2? They'll literally be the same thing. But that's weird because usually when I have a quadratic, there's two answers, right? I usually get two answers, and usually they're different. This is two answers, but the trick is they're the same answer. Okay, so if we think about it real quick, if we either graph this out, x equals 2. Okay, so I know that's where it crosses the x-axis because that's a real number, but it only crosses there. But so let's go through the rest of the end behavior here. So I go back and I look at the very first term, 1x squared. All right, so it's +1, so that means it's positive. The exponent is 2, so that means it's even. And if it's even, both ends will go to the same direction, and they're both going up because it's positive. And I look at the exponent 2, so that means there has to make one turn. So positive, even, they're both going up, and the graph's going to make one turn. So how is that possible, though, if I only have one x-intercept? Because usually I would have 2. Well, think about it this way. What if that's where the vertex was? Right? What if I did this? Went down and came back up. Still a quadratic, still a parabola. It's still both ends going up, but notice that the only place it touches is there at the vertex at 2. So that one just was peculiar because usually I get two different answers and I get two x-intercepts. This one only had one. And notice how it only touches there at the graph once. So use that, and we're going to talk about this more as we go on. If we ever get a duplicate answer, meaning like we get the same answer twice, like x equals 2 different times, that is actually where the turning point is going to be. So we call this multiplicity. So going back to the factors, x minus 2, I could have wrote x minus 2 squared, right? I could have wrote that like that. So that is a multiplicity of 2, meaning that is a turning spot on my graph. So whenever I have multiplicity happening, that's actually going to be a spot where my graph will reflect, or that is the turning point where it's going to go from decreasing to increasing or from increasing to decreasing, depending on, again, the rest of the end behavior and where the x-intercepts are. So that's just to give you an idea and a little preview, but just wanted to show you this one.